Hello everyone, my name is Rilla Dinesh from CSITA section. My technical concept of discrete mathematical structures is uncertain graph specification. Let's see the introduction first. Uncertain graph specification is a technique used to reduce the size of uncertain graph while preserving the essential structure properties. It involves selecting a smaller subset of edges from the original graph that retains the uncertainty information. The goal is to maintain two overall graph structure while reducing computational complexity and storage requirement. Here we can see that the graph here is a purple, blue, and brown reddish color refers to different categories. Now we will see about motivation. Uncertain graph arise in various real-world applications such as social networking, biological networks, and transportation network. These graphs often contain a large number of edges or nodes, making it challenging to perform efficient computation on them. Uncertain graph specification can help address these issues by reducing the graph size while minimizing the loss of important information. Now we will see about the key concepts. Uncertain graphs are represented using probability distribution over edge where each edge has a probability of being present or absent. Specification involves selecting a subset of edges that best represents the uncertainty in the original graph. The selecting edges should capture the important convectivity pattern and maintain the overall graph structure. Here it is a here it is a graph given it is related to months and temperature. Here we can see that it has a different type of colors which different type of colors indicates a different type of temperatures like Fahrenheit. F means Fahrenheit. Here we are calculating temperature in Fahrenheit. Here we can see that January has a different type of color, February, March, like that. Here we are having different type of colors. Each color have different meaning and different concept. Approaches. Different approaches have been proposed for uncertainty graph specification, including sampling-based methods and optimization-based methods. Sampling-based methods randomly sample edges from uncertainty graph based on their probabilities. Optimization-based method formulate specification as an optimization problem and aim to find the subset of edges and that minimizes a certain object functions. Method a RODEF anchor assigned part 2. Here we have a different types of edges and nodes. Nodes are connect. Different type of edges are here we can see the flow of that edges of ball. Start traversal at universal node. These are nodes and these arrow signals are showing how their nodes are linked to each other and directions of that. Okay, here start traversing unvisited nodes and traverse forward until a visited node is reached. And second, make a node and anchor. Sampling based method. Now we will see the sample approaches. Approaches first one is a sample based method. Sample based method randomly select edges from uncertain graph based on their probabilities. One common approach is to sample edges independent according to their probabilities, which leads to a subgraph with reduced size. Another approach is to perform a random walk on uncertain graph and select edges encountered during the walk. Type of sampling methods. Here we have a type of sampling method. First one is random sampling method and stratified sampling, systematic sampling, and non-random sampling and capture sampling. Description. Gathering a representative example from from a population where each member is the population has equal chance of being selected. Example, using a random number of generated student in class to complete task. Stratified sampling. Stratified sampling. Smaller group of strata within a sample are represented properly to the population. Finding out, it is an example now, finding out a favorite soap opera from different age categories of people in a year group. Systematic sampling. Every member in the population is given a number. After the first member is chosen at random, the remaining member are chosen from given interval. A list of peoples with their first name is an alphabetical order and a number. Now we will see about a non-random sampling. A conventional sampling is used to a user for ease of data collection. Volunteer usually collect data. Example: asking people at a given location about a log their commute to work. Is this? Now we will see about optimization based on method. Optimization is based method for valid uncertainty graph specification as an optimization problem. The object function typically consider both the preservation of a graph properties and the reduction in size. The optimization problem can be solved using various techniques such as linear programming, greedy algorithm, or spectral method. These are three types. First, these are the three types of graphs as we can see here. Now we will see about evaluation metrics. To, to assess the quality of uncertainty graph specification, various evaluation metrics can be used. One common metric is the preservation of a graph property such as average path length, clustering coefficient, and degree of distribution. Another metric is the reduction in size measured by number of edges or nodes in the specification graph. Now we'll see the applications. Uncertain graph specification has application in various domains, including network analysis, data mining, and machine learning. It can be used to improve efficiency of a graph algorithm by reducing the computational complexity. It also be applied to a large-scale uncertain graph data sets where storage requirements are a concern. Now we will see the challenges. Uncertain graph specification poses several challenges that need to be addressed. One challenge is to find an appropriate trade-off between graph size reduction and preservation of important information. Another challenge is to design efficient algorithms that can handle large-scale uncertain graph in a computational tractable manner. Here we can see the different types of graph structures. It is a graph structure GC1 layer, GC2 layer 2, or these are all the different types of layers. Now we will see the future direction. Uncertain graph specification is an active area of research with several future directions. One direction is to develop more advanced optimization techniques that can be better capture uncertain structure in the original graph. In another direction is to explore application of uncertain graph specification in a specific domain such as healthcare or social media analysis. Now we'll see the conclusion. Uncertain graph specification is a technique for reducing the size of a certain graph while preserving the essential properties. It offers a way to handle large scale uncertain graph more efficiently and effectively. Further, research and development in this area can lead to improved algorithms and applications in various domains. These graphs are used to improve our algorithms and development, mainly for algorithms in various types of domains. Let you will be in computer science or mathematical, wherever this is used to develop our algorithms. These three are reference. You can take that. Now we will see the acknowledgement. Special thank to researcher who contributed to the field of uncertain graph specification because it is a time taken research. It will take more time to research and to make a graph. Thank to colleague that better for their support and guidance throughout this presentation. Okay, thank you.